What happens in your body during a fever? The human body maintains an average temperature of around 98.6 degrees Fahrenheit or 37 degrees Celsius. The hypothalamus, a part of the brain acting as a thermostat, constantly monitors and regulates body temperature. During an infection, immune cells release fever-inducing chemicals, which travel to the hypothalamus and signal it to raise the body's temperature. This increase is typically considered a fever when the body temperature exceeds 100.4 degrees Fahrenheit or 38 degrees Celsius. The hypothalamus utilizes various mechanisms to raise body temperature, including constricting blood vessels to reduce heat loss through the skin and inducing shivering to generate more heat. Fever is part of the body's first line of defense against infections. Higher body temperatures create a less favorable environment for bacteria or viruses to replicate and infect cells. The immune system becomes more effective at fighting off infections by producing heat shock proteins during fever. These heat shock proteins activate immune pathways that help in defending the body against foreign invaders. Some people experience chills during a fever, despite rising body temperature. This happens because the brain has temporarily reset the internal temperature gauge to a higher level. A person with a fever may feel cold as the body tries to reach this new temperature. While fever is often uncomfortable, it is a natural and effective tool in the body's arsenal for fighting infections, and it usually indicates that the immune system is actively working to restore health. Why are some people taller than others? It's all in our genes. A recent study found 30 rare gene variants that can impact a person's height. These variants can either increase a person's height by up to 5 centimeters or decrease it by up to 7 centimeters compared to individuals without these variants. The study discovered these variants by looking at the genes of over 300,000 people. They also found that these rare gene variants are not very common, affecting less than 1% of the population. However, they can have a major impact on a person's height. Our height is mainly determined by our genes. About 80% of our height is influenced by differences in DNA inherited from our parents. However, we don't know exactly which genes are involved or how they affect our height. For example, a change in just one gene can lead to achondroplasia, a rare condition where people are shorter. However, for most people, how tall they are is determined by several genes working together, with each gene having a small impact on their height. Environmental factors like nutrition also play a role. Some people choose to go for a height-increasing surgery, also known as limb lengthening. This medical procedure adds inches to a person's stature. The complex process involves surgically breaking the long bones in the legs and then gradually stretching them apart using specialized external or internal devices. Over time, new bone, nerves, arteries, and skin will slowly grow to fill the gap.
Have you ever wondered why finding some people's veins for blood tests is hard? Age can cause skin to thicken and lose elasticity, obscuring veins, while dehydration can flatten them. Higher levels of body fat might put the veins deeper in your skin, making them harder to detect. Certain medical conditions can mask veins and make them less visible. Temperature also affects vein visibility. Cold temperatures can cause veins to constrict and become less visible, while warmth can have the opposite effect. Some individuals may have smaller or deeper veins, making them harder to locate and access. This is especially true for individuals with higher body mass. Veins prone to movement during needle insertion, known as rolling veins, can also pose a challenge. Stress and anxiety can cause vasoconstriction in the skin, making the veins harder to locate. Factors such as dehydration, surgical shock, past injuries, or scarring from frequent blood tests can further complicate this process. Repeated intravenous drug use can damage and collapse veins. In medical settings, ultrasound machines can assist in identifying veins. The standard blood drawing technique involves using a tourniquet to dilate veins in the lower arm, making them accessible. However, if the tourniquet is placed too tight, no blood can flow into the lower arm, resulting in hidden veins. If the tourniquet is too loose, venous blood can leak and cause deflated veins.